I'm going to try to make today's videos a little bit shorter because really most of today is something you already know how to do. Actually, two things you already know how to do. The first thing is what we've just been practicing, factoring. And the second thing that you should already know how to do is actually from middle school, just solving some basic equations. So our goal really today is to take a quadratic, factor it, right? And then solve it. So essentially, that's the wrong thing. Essentially what we're trying to do is we're trying to solve something, and the way we're going to solve it is by factoring it, okay? But there's one main thing we've got to make sure is the case before we do anything else. Before we do anything, we've got to make sure that every single equation we solve, before we solve it, every single equation has to be equal to a big fat zero. It's got to be equal to zero. If it's not equal to zero, then you can't even start. You've got to get it equal to zero. So once it's equal to zero, we follow three basic steps. We're going to factor, right? We're going to factor it. We're going to set each factor equal to zero. I don't know why that disappeared there. And then once it's equal to zero, it'll make it really easy for us to solve for x. So, like I said, I'm going to try and keep this short. I'm going to do a couple examples with you, and then you guys can try the rest. So notice on these first three, they're actually already factored. These are already factored. Here's factor number one, factor number two, right? It's already factored. So if we look at our steps, they're equal to zero, check. They're already factored. So step two means to set each factor equal to zero. So I'm kind of skipping the factoring part, and we're jumping straight to the solving part. So what we do is we set each factor equal to zero. The way I like to do this, let me zoom in so you can see really carefully how I do this. The way I like to do this is I like to draw a big line underneath, and then I like to separate the two factors where they meet, right? So those meet right there. If I was doing example 2 over here, big line underneath, and then separate them where they meet, right? And the reason why that is because we have to set both of those factors equal to zero. So I just come back and I say, okay, this factor is simply x. This factor is simply x plus 4. But for both of them, I'm going to set them equal to zero. All right? And by doing so, we actually just found one of my solutions. My first solution over here is zero. X equals zero. That one's done. But for the right-hand side, this is where I said we're going to bring back a little bit of middle school. We just have a really easy one-step equation. How would we get that plus 4 to the other side? We would subtract it. So if we subtract 4 from both sides, we're left with x equals negative 4. And that's my second solution. So when we factor trinomials and then we solve them, almost always you're going to get two solutions. All right, we're going to get two solutions. Not all the time, but especially when solving by factoring, you're going to get two solutions. So the way I present my solutions, this is not required, but it's the formal way. You present solutions using curly brackets. All right, curly brackets. They take a little bit of practice to do, but they're fun once you get a hang of it. So our two solutions are negative 4 and 0. That is not a coordinate. Those are my two solutions, the negative 4 and the 0. That's it. We've just solved by factoring. All right. I'm not going to take quite as long on these other guys because it's actually pretty easy. If I take these two and I set them equal to 0, 2x plus 1 equals 0, and 3x minus 4 equals 0, well, now we can just subtract the 1 over and then eventually divide by 2. So 2x equals negative 1 divided by 2, so x equals negative 1 half. Hopefully you're going to get even faster at this. Plus the 4, divide by the 3, so we're left with x equals 4 thirds. All right, that's what we're trying to do here, is we're setting the factors equal to 0 so that you can tell me what my solutions, what x actually equals. All right, now let's get to where we actually have to factor, right? What if it's not already factored? Well, I'm hoping that you recognize that first one right off the bat. It's been a couple days since we've factored just like this, but two terms, subtraction, and they're perfect squares, right? So if you remember that one should factor really quickly. Two binomials, x, remember we're taking the square roots, So the square root of x squared was x and x. Square root of 64 is 8. And one of them is plus, one of them is minus. Now, remember, it's equal to 0 now. So what we do, we draw our big line underneath, split them where they meet, and set each side equal to 0. X plus 8 equals 0, and x minus 8 equals 0. So this is kind of silly because you can see that your solutions are just going to be the opposites, right? X equals negative 8 and x equals positive 8. Those are my two answers. Those are my solutions. Number 5 takes a little bit of work here because here's the problem. It's not equal to 0. So we've got to get it equal to 0. And there's a few ways you can do that. But my recommendation is it's always going to be easier when this guy is positive. So I'm actually going to, instead of bringing the negative 121 this direction, I'm going to bring the negative x squared. I'm going to add x squared to both sides. That way I can get this guy positive. So if I add x squared to both sides, my new equation is 0 equals x squared minus 121. Now it's equal to 0. Check mark, right? So since it's equal to 0, I can factor it the same way I just did. X plus 11, because it's the difference of two squares. X minus 11 still equals 0. We split it down the middle. So you can probably already start to tell me if I set this equal to 0, well, the solution is just going to be the opposite, negative 11. If I set that equal to 0, the solution is going to be positive 11. So we're starting off with some easier ones here, but I'm hoping you're seeing just kind of how this starts to come together. Number 6, before we move on to the next video. Number 6, we've got to get it equal to 0. And once you do, if you subtract that 2x squared over, it is a like term over here. So that combines, you're going to see that it's x squared minus 81. Look at that. Two perfect squares. Your solutions are going to be 9 and negative 9. On the next video, we're going to jump into some slightly more challenging factors.